This is my recover project. These are defining constants. The buffer size is 512, file size is 8, and this is the data type of byte. So the uint at would be byte, so that it's easier to write when we use it multiple times in my code. And this is my main function. So this is checking if the user entered the correct number of command line arguments. So if argc does not equal 2, which is the number of command line arguments that the user is supposed to enter, then it'll print f the correct usage and then return 1, which means exit the program. And this is opening the memory card using fopen, and it's using the argv index 1, which is what the file name that the user entered, and this is in read mode for R. And this is checking if the file can be opened. If file equals null, then I'll print that file could not be opened and return 1. And these are declaring the variables, including the buffer size, and the first JPEG. This defines the variable first JPEG as 1 to show that the first JPEG has not yet been created. So if the first JPEG is finished, then this would be redefined to something else. This is the file number, the counter, and this is the file name, the file size, and this is the file, the image file. And this giant while loop is it basically repeats reading and writing the file until the end of the memory card. And while 1 means to repeat endlessly, and then it'll fread. This basically reads the file, okay, from basically reads 512 bytes from the file and then stores it in buffer. And this is basically FEOF returns a non-zero value when the end of the file is reached. So if the FEOF file does not equal 0, which means that the end of file has been reached, then break, which means exit the loop. And this is looking for JPEG signatures. So if buffer 0 equals this and buffer 1 equals this, and etc., etc., then if there's a JPEG signature, basically, then first I'll check if it's the first JPEG, which means first JPEG equals 1, which is what we defined up here. Then I'll use sprintf to make the file name, store the file name, and use fopen to open a new file that I defined up here in write mode. And then this is checking if the file can be opened. Image equals null, then print file could not be opened and return 1. And this will redefine the variable first JPEG to indicate that the first JPEG is finished. So this will equal to 0, which means that for the rest of the blocks that it reads, it won't go through here because it won't be the first JPEG anymore. And the else, this is for all the other JPEGs except for the first one. Then it'll go in here. This basically uses fclose to close the previous file that was open, and increment the counter for the file name. So the file num plus plus that I also defined up here, it'll increment it every time for the new file name, and then sprintf basically creates a file name with the incremented file number, and this uses fopen to open the file in write mode, and this is checking if the file can be opened again, printing out file could not be opened and returning 1. And after that, it'll always write the file using fwrite. It'll write from buffer into buffer that it read into the image file for the JPEG. So basically what happens in this loop is so it'll go through it infinitely, and it'll only exit when the FEOF for file does not equal 0, which means the end of file has been reached. So it'll always first read the file, 512 bytes, and store it in buffer, and it'll look for a JPEG signature. Um, and then if there's a JPEG signature, then I'll first check if it's the first JPEG, which means I'll open the file and then write. Or if it's not the first JPEG, then I'll close the previous file, increment the file file number, and then open the new file, and then write the file. And if there was already a file opened, then it'll just read and then write the file. So this process repeats until the end of the memory card has been reached. And then it uses fclose to close the latest image file that has been opened. And then finally it closes the memory card, which is the end of my code. So I'll run it. And when I run it, as you can see, it created 50 JPEGs with all these pictures.